Okay, with this particular section here, we're dealing with implicit differentiation. Differentiate implicitly, that's what we'll talk about. His steps right here. Now with a differentiate, using implicit differentiation for a function is where a function is written with the independent variables and the dependent variables are mixed together, and the dependent variable is it's an implied x, but it's not stated. We use implicit differentiation. We use this method to differentiate when we can't separate the y and the x, solve for y directly, or it's very difficult. Differentiate both sides of the equation with respect to x, or whatever variable you differentiate with respect to. Apply the rules of differentiation as necessary. Anytime an expression involving y is differentiated, dy dx will be a factor in the result. I'll isolate all the terms with dy dx as a factor to one side of the equation, factor out the dy dx, divide both sides of the equation to isolate the dy dx. So let's take a look at an example here. The first one here I have So I have 2 So what I can do here is factor out the 2. Factor out the 2, and then I'm taking the derivative of that part here. dx of this function here, xy. Plus I'm taking the derivative of 3, and I'll be taking the derivative of 0. Derivative of 0 is 0. Derivative of a constant is 0. Here I have a product rule. Remember the product rule? d dx of f times g is equal to f times g prime plus f prime times g. So I'll let this be my f, and let that be my g. Okay. So I'm going to have 2 times f. It's going to be what? X times derivative of y. Since this y is some implied function of x, the implied derivative is just going to be y prime times f prime, which is x, which is just going to be 1, times y, times g, which is just y. Now you can see that over here, if f is equal to x, then f prime is going to be 1. If g is equal to y, in this case here, implicitly with the y function here, g prime is going to be equal to y prime. It's an implied function of x. We don't know what it is. It's an implied function of x. Okay, and that's going to be plus 0. So when we get to that point there, we want to go ahead and solve for y prime. Understand that dy dx is the same thing as the first derivative of y prime. So I'm going to have 2x y prime plus 2y is equal to 0. Okay. And from there, you can see what they did next. Now, in this case here, after you get to that point, you want to solve it for y prime. So you try to get y prime by itself. So I subtract 2y from both sides and divide by 2y. 2's cancel and I'm left with that right there. I'm solved it for y prime, which is the same thing as dy dx. Let's look at another one. So in this case here, I have xy plus y squared is equal to 1. So I want to take the derivative of both sides. Derivative of a constant here is 1. Okay, so we'll be taking the derivative of this whole side here, and here I have a product. So I'll be taking the derivative of this product, and I'll be taking the derivative of y squared. So here we have that product. We did one earlier, so it's going to be x times y prime plus y. And for this one, we have y squared. Then in this case here, y represents some function of x. We don't know, it's an implied function of x, so we differentiate it like it was an implied function of x. So those same properties would carry over, applied to that y function. So I have 2y, y prime. So I've taken the derivative of everything. Now I want to collect my y prime terms and get y prime to one side. So I'm going to subtract both sides by y. Notice I have a common factor of y prime. So I can factor out the y prime here and divide both sides by x plus 2y. And that gives me my value there. I solved it for y prime. Let's look at another one. See here I have x squared minus xy plus y squared equal to 3. So I differentiate each term here with respect to x. So I have dy dx. Okay, so here I break this down. I differentiate the derivative of x of 3. And here I'm going to have to take the derivative of x squared, the derivative of this product, and the derivative of the y squared. So we did that product earlier. We have xy prime plus y. Derivative of x squared is 2x. And here the derivative of y squared is going to be 2y times y prime. Okay. And the derivative of a constant is 0. So now that I've gotten to this point here, I want to get y prime on one side. I want to solve it for y prime. So I moved the 2x to the other side and changed the sign. I moved the y prime and I changed the sign. So I have a common factor of y prime. Factor out the y prime and I divide by. There, and I've solved it for y prime, which is the same thing as dy dx. Here's another one. So I want to solve it by using different implicit differentiation. So I take the derivative of both sides here. Okay. So I have to take the derivative of x squared, the derivative of 2xy, and the derivative of 3y squared. So the derivative of x squared is going to be 2x. Then I factor out the 2 here, and I have the derivative of a product, xy. And the derivative of that product is going to be x y prime plus y. And the derivative of 3y squared is going to be 6y y prime. So now what I want to do is collect my y prime terms and solve for y prime. Okay. So I go ahead and I move my y prime terms to one side. So I'll subtract 2x y prime for both sides. And then I have a common factor of y prime and a factor out the y prime. Then I divide by. So even after I get to this point, notice all my coefficients are even numbers, so I could factor out at least a 2 here. So I factor out a 2 and it cancels, and there's my answer there. I solved it by solve for dy dx using implicit differentiation. Here's a different one here. So I'm going to solve this one by using implicit differentiation. So I take the derivative of both sides. The derivative with respect to x. The constant is going to be 0. I have to take the derivative of x to the fourth. I have to take the derivative of this product. So remember that rule. So the derivative of x to the fourth will be 4x to the third. And here I have a product. Okay. So I have the first one times the derivative of the second one, plus the second one times the derivative of the first one. So in this, the second one here is 3y y to the third, so that's going to be 3y squared times y prime is equal to 0 because the derivative of a constant is 0. So I've taken the derivative of everything. Okay. Now I want to go ahead and solve for y prime. So I go ahead and move my y prime term to one side. So this is the only y prime term here. So I move that to one side. Then I divide by, so I have y prime by itself. In this case here, I have a common factor of x. So I factor out a x, and it cancels. And I solve for y prime using implicit differentiation here. Now, let's look at some examples, more examples here. In this particular example, solve dx using implicit differentiation. So I take the derivative of both sides. So I take the derivative of y to the third. I take the derivative of that product. I take the derivative of x to the fourth. I take the derivative of a constant, which is 0. So the derivative of y to the third is going to be 3y squared times y prime. Okay, with respect to x. And here I have a a product. So I have the first one times the derivative of the second one is going to be what, 5y to the fourth y prime, plus the derivative of the first one, which is 2x times the second, which is y to the fifth, minus the derivative of x to the fourth, which is 4x to the third. So now that I've done that, I want to collect my y prime terms. I have one y prime term there and one y prime term there. Okay, and get everything else to the other side. So 4x to the third goes to the other side, and 2xy to the fifth goes to the other side, and the signs change there. So now these two terms have y prime in them, so I could factor out a y prime, and then I divide by. Okay, and then they want to find the slope of the tangent line, so they want to find out what is the slope at that point. So I'll put in 0 and 3 here to find the slope of that point. So the slope of that point is 0. And that's all they ask you to do, is to find the slope at that point. Here's another one. For this one here, they ask us to imply use implicit differentiation. So I take the derivative of both sides. So I take the derivative of each piece. So I have here on one side I have the derivative of, I have to take the derivative of y squared x, that's a product. Then I have to take the derivative of another product. So in this case here I factor out the constants. Then I also have to take the derivative of y plus 1. That can be broken down into derivative of y with respect to x and the derivative of 1 with respect to x. So the derivative of 1 with respect to x is 0. The derivative of y is going to be y prime with respect to x. Okay. Here we have a product. So we have the derivative of the first one times the derivative of the second, which is going to be 2y prime, plus the derivative of the first one, which is 1, times the second one, which is y squared. So I factored out a 2 here. So I have the first one times the derivative of the second, which is going to be 3y squared y prime, okay, plus the derivative of the first one, x to the third times the second. So I'm using that product rule here. So I've taken the derivative of everything. Now I want to collect my y prime terms. Okay. So I want to collect my y prime terms. So I see y prime there, y prime there, and everything else goes to the other side. Okay. So if you get confused about this a little bit, you can do this too. Y prime terms. Let's see here. That term has a y prime in it, and that one has a y prime in it. So everything else will be going to the other side. So I distribute here first, and I have 6x, and I have 2 here, y squared. So I send everything else to the other side. The y squared. See all my y prime terms on one side. I already had a y prime on one side, so that's where that came from. So I've got my y prime terms here. Factor out the y prime term by itself, and then divide by. And that's how you approach that one there. And I solved it for dy dx using implicit differentiation. It's a demand function here. It's differentiated implicitly. So I'll rewrite this radical with an exponent. So I take the derivative here with respect to x. In this case here, dp dx. Isn't dy dx, it's dp dx. Okay. So when I take the derivative here of what's on the inside, I'm going to have 3p squared, 3p squared p times p prime. And that's a negative 3 there, because there's a negative there. Okay. Then I rewrite this with the radical. And here we have the derivative of x is equal to 1. So I have it there. Okay, so now that I've taken the derivative of everything, I want to go ahead and solve it for p. So I multiply it by the reciprocal, and now I have p prime by itself. And that's the same thing as dp. It's the same thing as dp over dx. That's the same thing. Okay. If variables x and y are related to one another by an equation, but neither variable is isolated on one side of the equation, we see we have an implicit relationship. To find dy dx without solving an equation for y, we use the implicit differentiation. Whenever we implicitly differentiate y with respect to x, the factor dy dx will appear as a result of the chain rule.